Hello all, previously we have seen how to delete a node at the beginning of circular SLL. Now in this particular video we will see how to delete a node at the end of circular SLL and how to delete a node at a specific position in circular singly linked list. So these two operations we will discuss in this video. So let's get started. So for that purpose I am using a function called delete at end. So delete at end. So first we have to check the condition if head double equal to null or not. If head is null, then linked list is empty. We don't have any nodes to be deleted. If there are some nodes in the linked list, then take a temporary pointer called temp, which should be pointed to tail. So what I am highlighting now, this temp will be the node, that is what we are interested to delete. So this temp will point to tail. Okay, suppose there is only one node in the list. So if only one node is present, that is the first and last node, right? So for this purpose you have to check the condition. If head double equal to tail, then that linked list contains only one node. Then make head and tail both as null value, and then you can freely delete the temp value. So you can freely delete that node itself. For suppose there are some nodes present in the list, then you need to create one more pointer called current, and which should be pointed to head. Okay, so why this is required? To find the second last node. How to find the second last node in circular SLL? So while current next not equal to tail, since we don't have any null values, so current next should not equal to tail, then we have to move the current pointer to the next node. By the end of this loop, current will point to the second last node, and then make we have to find the we have to form the circular reference, right? So current next is equal to head, so that the second last will becomes the last node, that will form the circular reference, and then move the tail pointer to the current node, so that tail pointer will be updated. Then you can freely delete that temp node. Instead of going through each and every line of the code, I will show you the example. I will explain with that example, that would be better. So let us assume we have a linked list like this, and initially the head is pointing to the first node and tail is pointing to the last node. In this case I want to delete the last node. That is what delete at end function will do, right? Now since circular SLL has more than one node, so take a pointer called current that will points to head. So in this diagram I have taken the current at the first node, and take another pointer called temp, which will be pointed to tail. This node I am interested to delete. That means the last node I am interested to delete. Okay, that is what this function will do. Now take another pointer called current that will point to the first node. We have to traverse this current node, current pointer, to find the second last node, in this case the second node. How do we do that? For that purpose we need to traverse the list, right? So traversing, I have written some code here. While current next not equal to tail, as long as current next not equal to tail, we have to move the current pointer to the next nodes. So after completing this loop, the updated diagram as follows. Now 100 is placed at the head is placed at the first location, and current is placed at the second location. After finding the second last node, we have to form the circular reference. How do we do that? So by the help of this statement, whatever the head value, that will be assigned in current next. So initially the current next value is 300. Now update this with head value. So current next value updated with 100, so that the circular reference is formed. Okay, then make the tail pointer point to the second last node. How do we do that? Tail is equal to current. What is the current address? 200. That will be assigned in tail, so the tail will move to the current node. So this is the updated diagram. Now you can freely delete this temp, okay, by using a memory deallocation function called free. So this is defined in stdlib.h. So we have discussed in our previous videos, right? We can delete this temp by freeing the memory location, and this is what the updated linked list. Okay, so let us run this code so that you will have a better understanding. Execute and compile and run. I will add some nodes by using insert at end function by a choice called 2. I am adding 10, I am adding 20, I am adding 30. Okay, so I will display the initial linked list. So this is the initial linked list. I mean to say circular SLL. You can delete the node at the last. I mean, you can delete a node at the last by using a delete at end function by a choice called 5. So 5, that means 30 will be deleted. The updated linked list as follows. So 30 got deleted. So in this fashion, you can delete a node at the end of circular SLL. So we will see another function called how to delete a node at a specific position. If specific position is given by the user, how to delete a node at a specific position. So by that, for that purpose, I am using delete at position. It is a user defined function which is taking one argument called position in position. First of all, check if head double equal to null. Then if head double equal to null means then linked list is empty. We don't have any nodes to be deleted in this case. Suppose then take another pointer called temp and points to head. Now deleting the first node. How to delete the first node? If position double equal to 1 means whatever we have discussed how to delete a node at the first node, that code will be here. Now if head double equal to tail, that means if only one node is present, then make head and tail as null, and then you can freely delete the temp. Otherwise you move the head pointer to the next location and form the circular reference, and then you can delete the temp. This is what we have discussed how to delete a node at the beginning of circular SLL. The same code is written here. Okay, nothing very new in this case. But if there are some nodes and you want to delete a specific node, in this case the case number 3 will come into picture. Then in this case you take another pointer called priv. Initially it will be null. So to find the previous node, in order to delete that particular node, we have to find the previous node to form the connection from the previous node to temp next node. Okay, so instead of going through this each and every line of the code, I will take an example diagram. I will explain through that example. That would be better. So maybe it will be confusing if I explain each and every line of the code. I will explain anyhow, but I will take an example and I will explain the code. That would be better. So for example, let us say we have circular linked list as follows. We have 1 2 3 4. I want to delete a position 3 value. That means this 50 I wanted to delete. For that purpose, take a priv pointer. Initially the head will be placed at the first pointer, right? So for this purpose, now we are taking two pointers. One is temporary pointer which will be pointed to the first node initially, and take another pointer called priv to find the previous node. Okay, initially previous is null. For that purpose, make a traversing. In traversing code, you can take any loop. I am taking do while loop. Now priv is equal to temp. Temp and priv both will point to the first location. Okay, temp and priv. Temp will point to the head location first of all. So I will show you the code. Now here see this line. Temp will pointing to the head node. That means temp and head points to the first node itself, right? Now take another pointer called priv. Initially it will be null. Now points to the temporary part. That means priv will point to the first node itself, and temp should be moved to the second location, and subsequently increment the count value. So while temp not equal to null, In this case null is not there, I am sorry. Then how to indicate that is the end of circular SLL? To find if last node is having the first node address, then that means we have come to the last node of circular SLL. How to do that? Temp not equal to head and count less than position. So we need to check this condition to check we have not crossed the your given position value. Okay, then after this loop, this is what the expected diagram looks like. Now initially head will point to the first node, prev will point to the previous node, and this temp we have to delete this temp. In order to delete this temp, you cannot directly delete this temp. First make a connection to second and fourth one. Second and fourth we have to form the connection. How do we do that? So in previous next part, assign the tile part. I mean, not the assign the tile part, with don't assign the tile part directly, because here only one node is present after temp, so you cannot directly assign tile address here. So if there are some multiple nodes present in between temp and tile, then assigning tile in previous next is not the best idea, right? Then take the temp next value and assign in the previous next value. The updated diagram as follows. We don't have a connection between prev and temp. Okay, now we have formed the connection between previous and the temp next node. The temp next node, in this case the tile node, but in this case we have only one node is present after temp, that is a tile node. In real world scenario there might be some other nodes, so you don't take any. In this case some may say we need to assign tile address in the prev next part. So what is the tile address? 400. The temp next is also 400, but if you have given tile address in the previous next node, if there are, assume there are some nodes, then this code will not work. So in order to overcome this problem, take temp next value and assign in previous next part, so that we will check the boundary conditions perfectly. So next you can freely delete this temp by using a memory deallocation function called free, and you can delete this temp. The updated diagram as follows. Okay, so this is the code. For example, if temp double equal to head means, then we have position out of range. Now you in this case you have given a value which is greater than 3. In this case we have taken only 3 nodes, right? So we have taken only 4 nodes. After 4 nodes you have given any other value, then this condition will gets executed, temp double equal to head. This is a homework for you. Check if this is working or not. If your position value is greater than the nodes value, this condition should work. Okay, so if temp double equal to tile, that means if you are deleting the last node, then make the tile pointer update. I mean tile is equal to update the tile part. Okay, if temp is equal to tile, then tile is equal to prev. So how do we do that? So if this is the nodes to be deleted, then tile should be moved to here and form the circular reference. Okay, temp tile equal to, if temp double equal to tile, then if for example assume the temp is at the last location. Assume temp is at last location, then make the tile adjustment, and then you can delete the last node itself. Okay, so that's it. I will execute this code. So I will rerun this code for you. Execute, compile and run. Insert at end function I am calling 10, 20. Okay, I'm sorry, I will execute one more time. Execute, compile and run. I am adding the nodes with a function called insert at end. 10, 20, 30, 40, 50. I want to delete a node at third position. Before that, I will display the initial circular SLL. This is the circular SLL. I want to delete a node at third location. 1, 2, 3. 30 should be deleted. So what is the choice value now? The choice value is delete from position, right? So what is the value? 6. So enter position to be deleted 3. Now updated linked list as follows. So that is the got deleted. That means third node got deleted. So in this fashion you can delete a node at a specific position in a circular SLL. Thanks for watching. I will see you in my next video.